じゃあ、これから発表させていただきます。Good afternoon, everyone. Today we will present our research and opinions on hydrogen society in the Tokyo area. Our team consists of these four names, has explored the potential of hydrogen production, utilization, and its feasibility in this area. So we will start by discussing different methods of hydrogen production, followed by its utilization and analysis of its efficiency, and finally comes to our conclusion. Firstly, I'd like to share the definition of three main types of the hydrogen. The gray hydrogen can refer to the most common type, which is produced from fossil fuels such as natural gas and coal, and has low production costs. However, it emits carbon dioxide, which is a demerit. Secondly, is a blue hydrogen. This is derived from gray hydrogen by using carbon capture technologies to reduce emissions by up to 90% or more. Lastly, comes to the green hydrogen. It is produced through water electrolysis using renewable energy resources like wind and solar. This method generates no greenhouse gases, but is currently restricted by high costs and technology limitation. In this section, we'll discuss the potential of geothermal energy in the Tokyo area and its advantage over other energy sources. Firstly, let's look at the map on the left, which shows the locations of geothermal power plants operating in Japan as of 2011. The Tokyo region highlights there. This part. Yeah. Has several geothermal plants indicating its significant geothermal resources. Geothermal energy offers several advantages when compared to other traditional energy sources like coal, wind, or solar power. Geothermal plants require less land per gigawatt of energy produced, making them more space efficient, and they emit little to no greenhouse gases, contributing to a cleaner environment. Geothermal energy consumes less water over its lifetime energy output compared to other sources. One of the major benefits is its ability to provide a stable base load, consistently generating electricity 24 hours a day, regardless of weather conditions. Now, let's focus on the chart to the right. It illustrates the predicted growth of renewable energy capacity in Japan. According to the chart, PV stands for photovoltaic capacity is expected to increase significantly by 2030, driven by residential, industrial, and new applications. Furthermore, Japan's Agency of Natural Resources and Energy has projected that by 2030, domestic geothermal capacity will reach 1 million kilowatts, nearly tripling the capacity from 2019. This forecast highlights the growing importance of geothermal energy in Japan's renewable energy strategy. Given these advantages, utilizing geothermal energy to produce hydrogen is an excellent choice for the Tokyo region. It not only leverages the local resources, but also aligns with Japan's goal of reducing greenhouse gas emissions and enhancing energy security. By integrating geothermal energy into hydrogen production, we can create a sustainable and reliable energy source that supports the development of a hydrogen society in the Tokyo region. In terms of hydrogen utilization, hydrogen is a versatile energy source with application across various industries. Currently, its primary use is in industrial sectors, but in the future, it is expected to expand into more diverse applications. Hydrogen can be utilized in three major ways. Firstly, hydrogen can serve as fuel for transport, including ships and airplanes. Hydrogen-powered vehicles can gain attention as an alternative to traditional fossil fuels. In addition, hydrogen can be used in electricity peaking plants to produce to provide back power, enhancing energy grid stability. Hydrogen can be used for industrial and residential heating. It plays a crucial role in high-temperature processes, such as steel making, cement production, and aluminum refining. Hydrogen has the potential to be used for heating in residential and commercial buildings. Thirdly, hydrogen is an essential component in manufacturing. It is used in fertilizer, fuel refining, and plastic production. Hydrogen contributes to the production of steel, food, and glass. Looking at the graph on the right, we can see the projected hydrogen demand under an accelerated scenario. In 2020, hydrogen usage was predominantly in industrial sectors, accounting for 86 metric tons. However, by 2050, total hydrogen demand is expected to rise significantly to 404 to 469 metric tons, driven by new applications in power, mobility, and heating. The key observations from this trend may include power and mobility sector will play a larger role in hydrogen utilization in the coming decades. Secondly, heating applications will also increase, even so at a slower rate. Lastly, new industrial uses of hydrogen will expand, complementing existing industrial demand. Oh, sorry. Okay, now let's analyze the efficiency and the feasibility of hydrogen utilizations. As shown in the diagram, hydrogen can be used in different ways, but its efficiency varies across the applications. Converting electric power to hydrogen and then back to the electricity results in a low efficiency of 20 to 40%. This efficiency makes hydrogen less ideal as a direct fuel source for general energy production. The efficiency of hydrogen when used for heating is much higher at 70 to 80%. It makes it a more viable option for industrial applications that require high temperature process. When used in chemical and industrial process, hydrogen has an efficiency of 60 to 80% as a feedstock, making it one of the most effective ways of effective use of hydrogens. The map on the right illustrates the population distribution across Tohoku region. This region is characterized by a widely scattered population, meaning that large-scale hydrogen heating infrastructure will be difficult and costly to implement. Unlike densely populated urban areas, where centralized heating and energy systems are more viable, Tohoku's dispersed population makes it less suitable for hydrogen-based heating. In this section, we propose a solution for advancing hydrogen energy adoption, particularly in the industrial sector. To identify who, our answer is major corporations like Toyota, Denso. What? To identify what, the focus should be on producing metal use hydrogen or burning hydrogen for energy. To whom? The primary target for hydrogen adoption should be the industrial sector, as it currently has the highest demand and the best infrastructure to support hydrogen use. And the answer for with whom is that we need to collaborate with the government, which is essential to support hydrogen energy policies, infrastructure, and subsidies. So, but however, one of the biggest challenges with hydrogen is the high transport and storage costs. So, which just makes more difficult for regular consumers to afford. By focusing on industrial application first, the hydrogen economy can develop in more sustainable and economically viable way before expanding to broader consumer use. So here comes to the last three answers. So how, as we discussed before on page 6, is a structured process will guide the transition. And how much? Our answer is hydrogen production costs must be compared with traditional methods to ensure economic feasibility. And last comes when. So we reckon that the transition should start immediately with gradual adoption until technology advance sufficiently to make hydrogen affordable for everyday consumers. After announcing the potential for realizing a hydrogen society in Tohoku region, we have identified 4 key takeaways. Currently, hydrogen is mainly used in industrial applications. In order to achieve widespread hydrogen adoption, it is crucial to improve the energy conversion efficiency of hydrogen production and utilization. Secondly, the transition to green hydrogen heavily depends on the knowledge of the advancement and cost reduction. One promising solution is utilizing geothermal energy, like we discussed before, for hydrogen production. This approach offers a stable power supply and a reduced environmental impact, which makes it a viable strategy for sustainable energy development. Thirdly, one of the challenges in Tohoku is dispersed population distribution, which makes hydrogen less suitable for heating applications. However, industrial applications in this region show significant potential to support hydrogen adoption. Collaboration between companies like Toyota and Denso and the government is necessary. This cooperation can boost the regional industrial development while promoting the use of hydrogen technologies. Finally, despite the challenges related to hydrogen transportation and storage, and long-term technological advancement are expected to make hydrogen energy more accessible and affordable for the general public. This gradual progression will be essential in achieving the sustainable hydrogen-based economy. So in conclusion, realizing a hydrogen society in the Tohoku region will require collaboration between government, industry, and the researchers to overcome a series of technological and economic barriers. But we believe that by leveraging geothermal energy for hydrogen production could be a significant step towards to the sustainable future. That's all for our presentation. Thank you for your attention. ご清聴ありがとうございました。